Okay, this is lesson 4 in linear relations, and we will be working on identifying non-linear relations. So not all data form a straight line when graphed. So therefore, nonlinear graphs can take many different forms. What you're going to be seeing is curved lines. And we will have to be careful though, because on graphs, certain data points are going to look like they are linear, but we're going to have to check the slope. And a nonlinear graph is not going to have the same slope all the way along. So you're looking for curved lines and different slopes. Okay, so example 5. A secondhand store has a policy that if an item has not sold, it drops in price by 30% every 2 weeks. A wool coat started out at $50. And we're going to see how it drops in price. So create a table of values showing the price of the coat after 2, 4, 6, and 8 weeks. Draw a graph of the data, and then see, is the graph linear or nonlinear, and use slope to support your answer. Okay, so for A, the solution. Calculate the price of the coat after 2 weeks. The price decreases by 30%, so the price will be 70% of the original. Okay, that's often a common error, is people will calculate the 30% of the original price and they think that's what decreasing means. No, it means it went down by 30. So the coat is now 70% of what it once was. Okay, so for example, $50 times 0.70. Remember, you got to turn this into a decimal to use it. Okay, and you just go 70 divided by 100. And you're going to get that. So 50 times 0.7 is $35. So after 2 weeks, it is now $35. Then what you have to do is you got to take that new price, $35, and now after 2 weeks, the new price will be 70% of this price here, not the 50. Okay, that's also a common error. So 70% of $35 is $24.50. And then take that $24.50 after 6 weeks and times it by 0.70. It is now worth $17.15. And then $17.15 times 0.7 is $12.01. And here's your table of values. This is your independent variable. And the price will be your dependent because the price is dependent on the week. Okay, draw a graph. And here's all the points plotted: 50, 35, 24.50, 17.15, and 12.01. Now, you can see that this is not linear. Okay, there's obviously a curve to it. So for is the graph linear or nonlinear, you can just look at it and tell. You don't even have to calculate the slope here. So no, the graph does not appear to be linear. The change in the x value is constant. What it means is it just goes 0, 2, 4, 6, 8. Those data points are constant, but it's not going down by the same amount each time. And on the next page, we're going to prove this not linear, even though you can see it isn't, using slope. So they've chosen 24.50 minus 50. So they chose, where is the 50? Right there. They chose this one. Okay. So they noticed that it went down how much? negative, so they subtracted and got minus 25.5. So it went down 25.5 and over 4. So that's what all of this is. Remember, if you want to just jump right to here, go ahead. If this stuff confuses you, just do it with measuring. Okay. And we're going to calculate the slope here, and you're going to get negative 6.375. So what that means is between those 2 points, the slope would suggest dollars per week that the price is going down by $6.375 per week. Well, if you go to another set of data points between 1715 and 2450, so right here, okay, so they chose this. This is 2 over, and it went down. They subtracted the 2 and got minus 7.35. Okay, so divide this 2 by negative 7.35, and you get a completely different slope. And you can tell the slope is going to be less. Just look at the between the 2 points here. It's not as steep, right? Here it's more steep, it's curved. So there's just the proof. So the slopes between the 2 pairs of points are not the same. Therefore, it is not linear. Okay, so if you ever have to prove it using slope, that is what it's talking about. And that is the end of lesson 4. In the next video, I will be doing the Build Your Skills 11, 12, and then we'll be on to the assignment.